Now, when the double bond breaks, the electrons have to form a bond, right, somewhere. So if we have a look at our H, say HI in this case, we have H plus and I minus. So when the double bond breaks, we are left with a hydrogen either on the first carbon or a hydrogen on the second carbon. So that's the first step of the reaction. So our double bonds, the electrons will go up to this breaks, then you have your negative, your anion, but we're left with this is actually a poor example to use. Because they are both. So remember our carbocation, so this is secondary carbocation and this is also a secondary carbocation. So this doesn't explain it very well, but so you'd have them in like a 50-50 situation here. Alright, let me just copy all of this. Okay, so both of the carbons are secondary carbocations. Now, if, for example, that's what we did yesterday, so we have primary, secondary, and tertiary carbocations. Tertiary, secondary, primary. So it depends on the number of OR groups and the number of hydrogens around that carbon. Now if we were to look at this, and I'm going to take this out of it, and I'm going to change this. Okay, how do we know which carbon the hydrogen will bond to? I'm going to explain that to you now. Will these extra notes be on Moodle? I will be putting up extra notes on Moodle, but maybe not specifically these ones. So if, for example, we had CH3, so if our compound was 2-methyl, pent 2-ene, we would have a CH3 here. Right? So I'm actually going to take this here too. Okay, so how do you know where the ion goes? You're tracing the electrons and the path of the electrons. That's why I don't want to go into too much detail on it now, because I need to go back to the very beginning of this with you. But I just want to explain where the major and the minor comes from. So next week I'll be doing the reactions in more detail.